Hello, here is Andestan. In this assignment, I explore the relationship between linear and angular motion. I am going to calculate the distance traveled by the bicycle during 10 pedal rotations. I am also measuring this distance 5 times. I will compare the two numbers. Here is my bicycle. You can see that I measured the radius of my wheel, the radius of the gear of the pedal, and the radius of the rear sprocket. Here is my first run. As you can see, I started with the right pedal up, such that when it goes back up, it completes 1 revolution. I did this 10 times. When I stopped, as you can see with the white tape measure that's left of my bicycle, that distance is the distance where I stopped after 10 revolutions. Here you can see the results of my measurements. The radius of my gear pedal was 0.09 meters, the rear sprocket was 0.0275 meters, and the rear wheel was 0.29 meters. We measured centimeters, and then we moved the decimal over 2 times to get meters to the left. Here are the results of my 5 trials with riding my bike with 10 pedal revolutions. Trial 1 was 32.90 meters at 11.35 seconds. Trial 2 was 32.8 meters with 12.71 seconds. Trial 3, 32.16 meters, 14.01 seconds. Trial 4, 32.70 meters, 12.73 seconds. And Trial 5, 33 meters and 13.28 seconds. Then I added up all of the times and divided them by 5, and my average was 12.816 seconds. I also added up all of the distances and divided them by 5, and I got 32.712 meters. Here are the results of my calculations. The first thing that I calculated was the angular velocity for the gears of my pedals of my bike, moving in revolutions per second. I did 10 revolutions, because that's how many revolutions was done, divided by 12.816 seconds, which is my average seconds calculated over the 5 trials. I ended up getting 0.78 revolutions per second. Then I used that to calculate the angular velocity of it in radians per second. So I did 0.78 revolutions over 1 second, and because there's 2 pi radians in 1 revolution, I did times 2 pi radians over 1 revolution, and I got 4.90 radians per second. The next thing that I calculated was the linear velocity of the chain in meters per second. I did 0.05 meters, because that is the radius of the rear sprocket, divided by 1 radian, times 4.90 radians per second, because that's the angular velocity, which is 0.25 meters per second. Next, I calculated the angular velocity of the back sprocket of my bike, which is the velocity of point B divided by the radius of point B, which is 0.245 meters divided by 1 second, times 1 radian over 0.0275 meters. The linear velocity of point A and B are the same because they're connected by the same chain which has that velocity. My result was 8.91 radians per second. Part 5. Next, I calculated the angular velocity of the rear wheel of my bike in radians per second, which is the same as the angular velocity of the back sprocket, because the little wheel is inside of the big wheel. So that is the same as 8.91 radians per second. Part 6. Next, I calculated the linear velocity of my bike. I did 8.91 radians per second, which we calculated that angular velocity earlier, times 0.9 meters over 1 radian, because that is the radius of the big rear wheel of the bike. And I ended up getting 2.58 meters per second. Lastly, I calculated step 7, which is the distance traveled by the bike. So what I did was the velocity, which is the rate times the time, which is 2.58 meters, from the linear velocity that we calculated earlier, divided by 1 second, times 12.816 seconds, because that was the averages of the times that we recorded, which is 33.11 meters. Then I compared that to the calculated average of 32.712 meters, which is less than half a meter off. At this last step, I realized that I multiplied the time to the equation, but in the first step, I divided by the time. In my equation, at the bottom, the distance equals 10 times 2 pi times the radius of the gear pedal divided by the radius of the rear times the radius of the big bicycle wheel equals 33.13 meters, which means the time doesn't matter at all. Thank you for watching my video. I hope you enjoyed my presentation. Please enjoy riding your bike. Until next time, here is Andestan. Bye-bye.